Hey, it's NextGenNed. Stand by for fresh info on ATSC 3.0, NextGen TV, and 5G TV. Yeah. Did you know that ATSC 3.0 has been on the air in another country for a couple of years? Well, it's fact, and that country is South Korea. South Korea said, hey, we want to broadcast the Olympics. This is the 2018 South Korean Winter Olympics in 4K. And the only way they could do that was to go on the air with ATSC 3.0. So what they did was they said, well, you know what, we're just going to lock it in even though the ATSC has not locked it in yet. And we're going to build some sets, and we're going to build some transmitters and exciters, and we're going to broadcast the Winter Olympics in 4K. And that's what they did. Worked out fine. Everybody was happy. They got a lot of TV sets. They put in, I believe, 5 or 6 television transmitters in the metropolitan areas in South Korea, and it was a great success. Now then, fast forward to today, those sets are rapidly going to become obsolete because once America, and actually the ATSC organization, finalizes ATSC 3.0 and says, that's it, let's start building receiver chips, then that's going to obsolete what's in Korea right now. Of course, by that time, they'll be building ATSC 3.0 TV sets, NextGen TVs, cranking them out of the factories in South Korea just as fast as they can get them on the boats. So getting some new TV sets in South Korea is not going to be a big deal at that point, and they'll all be locked in. Now, the one thing about ATSC 3.0, as opposed to a lot of computer stuff, there's not going to be any kind of firmware upgrade for the receivership. When it's built, end of story. We can't make any changes after that unless we come up with ATSC 4.0 or 5.0 or wherever it ends up going. There's an organization that sets standards, practices, and protocols for cell phone systems, just like the Advanced Television Systems Committee sets standards for TV. It's called the 3GPP, Third Generation Partnership Project. 3GPP has been testing, I gotta read this one, further evolved multimedia broadcast multicast services, known as FEMBMS, since it was introduced in 2017. The tests in Germany are focused on the high-power, high-tower infrastructure common among most TV broadcasters. Most cell towers are intentionally low-power, low-tower, so they can receive weak, low-power signals from nearby handheld devices and to avoid congestion. FEMBMS allows 5G high-power, high-tower transmission in the downlink-only mode, just like TV is today, using the full signal bandwidth for multicasting. One HPHT FEMBS transmission overlay can cover, isn't that a mouthful, can cover the LPLT cellular network infrastructure in about a 37-mile radius. According to Verizon, the radius of LPLT 28 gigahertz 5G service is approximately 1/2 mile. Right now, activity in the millimeter 5G bands is above 10 gigahertz is experimental, but that's where the bandwidth is. The emerging ATSC 3.0 NextGen TV 5G controversy is beginning to come to a head one of these days. And it all started at NAB this year. I got to read this part. At NAB, where NAB CEO Senator Gordon Smith talked about a new broadcast receiver chip for mobile devices that can automatically receive local TV and radio stations in any country and in any format in the world, including ATSC 3.0 NextGen. In his opening remarks, Smith said, "What we would really like to see is a chip built right into the phone to give consumers this technology. As of right now, phone manufacturers refuse to enable broadcast chips in their devices," which is true. My FM chip doesn't work in this thing. Of course, no discussion of 5G would be complete without talking about the apparent dangers and health problems that might be generated by 5G transmissions, particularly in the millimeter wave range, and rightfully so. Right now, that range of frequencies, 20 gig to maybe 60 gig to maybe even 100 gig, that's all used for military crowd control. I don't see how that mixes, but okay. But aside from that, I gotta say, I worked at a TV station, the first place I worked at. The tower was right above the station. And 1,000 feet above the building, we were radiating about a megawatt of power. And you know what? People didn't live real long at that place. I didn't put two and two together until I worked there for about 10 years and started realizing, you know what, aside from people smoking a lot and dying from cancer from smoking, there was just a lot of people dying. Most everybody I knew that retired only lasted a couple of years. You know, I don't want to be one of those people. So once I kind of figured that out about 13 years into working there, I left. Well, you can't see the future of television on television, but if you like and subscribe, I'll tell you what I know as I learn it, because the future of television in the 21st century is changing before very few people's eyes, unless you found this channel. So please like and subscribe. See you next time.